Soderbergh's relation, takedown, and Goodman's. That's what we have learned in the previous class. A circular bar of 500 mm length, a circular bar of 500 mm length, a circular bar of 500 mm length is supported freely, is supported freely at its two ends, at its two ends, at its two ends. Full stop. It is acted upon by, it is acted upon by, it is acted upon by a central concentrated, a central concentrated, a central concentrated cyclic load, cyclic load, cyclic load having minimum value of 20 kilonewton, having minimum value of 20 kilonewton and a maximum value of 50 kilonewton, 50 kilonewton, 50 kilonewton. Full stop. Determine the diameter of the bar, determine the diameter of the bar by taking a FOS of 2, by taking FOS of 2, FOS of 2, comma, size factor 0.85, size factor 0.85, comma, surface finish factor 0.9, surface finish factor 0.9, full stop. The material properties of bar, the material properties of bar are given by sigma u is equal to, sigma u is equal to 650 megapascal. Sigma u is equal to 650 megapascal, comma, sigma y is equal to 500 megapascal, sigma y is equal to 500 megapascal, and sigma endurance is equal to 350 megapascal. Sigma endurance is equal to 350 megapascal. Okay? Yeah. You're all there? Akram Anwar? Akram, have you noted
Yes,
down?
sir. Yes.
You have noted down
Yes.
the problem?
Sir, no, sir. I was disconnected for a while, sir.
Okay. Chinmay,
Yes, sir.
have you noted down the problem in total?
No, sir, joined late. I have to take down the question from somebody.
Okay. Tarun,
Yes, sir. So, So,
Okay.
excuse me,
A
sir.
circular bar of 500 mm length is supported freely at its ends. So there is a circular bar. Okay, this is a circular bar which is supported freely at its length. I mean at its ends rather. And this length is, this bar is of length 500 mm. Okay. So a circular bar of 500 mm length is supported freely at its ends. It is acted upon by a central concentrated cyclic load. So it is acted upon by a central concentrated cyclic load with a minimum value of 20 kilonewton. Okay. So the minimum value of load is 20 kilonewton and maximum value of load is 50 kilonewton. Okay. So these are the two cyclic loads that it is acted upon. So it is a freely suspended bar with central point load where you have got minimum load of 20 kilonewton and maximum load of 50 kilonewton. And we are expected to find out diameter of the bar by taking factor of safety. FOS is equal to N is equal to 2 and we are given with size factor of 0.85. That is, size factor is the value of B is 0.85. Surface finish factor, that is 0.6.
Sir, the video is stuck.
Yeah.
We're not able to see what you're drawing, sir.
1 second. There may be some internet issue. Can you hear? There is some internet problem. It is stuck there.
Yes, sir. Now am I audible?
Yes, sir.
Yeah. Now it is okay. Yeah. Can you see the whatever I have written on the board?
Yes.
Yes, sir. Yes.
Yeah, there was some, I don't know, internet issue maybe there. Okay, yeah, this is a circular bar of length 500 mm, which is supported freely at its end. That is, the bar is within the bearings over there. This is acted upon by loads of 20 kilonewton to 50 kilonewton. So minimum load is 20 kilonewton, maximum load is 50 kilonewton. And we are given with the factor of safety of 2. The value of size factor is 0.85. Value of surface finish factor is 0.9. Since he has not talked about load factor, we take the value of load factor A as 1. Okay. And the ultimate stress of the material of the bar is 650 megapascal. Yield stress is 500 megapascal and endurance strength is 350 megapascal. This is what is given in the problem. Okay, are you with me? Can you see what is written on the board now?
Yes, sir.
Yeah. Now I take this bar as 2 bars. Okay, one acting with 20 kilonewton load at its free end. So this I call it as P minimum. Okay. So for this P minimum with a bar of 500 mm length, this is the value of L. So it is a freely suspended bar with central point load, and so therefore it says it's a transverse load. So therefore the bar is subjected to bending. Okay. So what stress you will have here? You will have bending stress, and bending stress is given by what? M by Z. Okay. Now we need to find out bending moment for a simply supported beam with central point load. The value of bending moment, okay, here I call it as bending moment minimum, is given by what? Is given by WL by 4. Can you remember this? We have solved several problems based on this earlier. Okay. So that is P minimum into L divided by 4. So what I am going to get here is P minimum is 20 into 10 power 3. Okay, into length is 500 divided by 4. So this will be my minimum value of bending moment for a 20 kilonewton load. Is it okay? Is it okay? Then I'll take the maximum value of load again. So there is another beam. Okay, there is same beam which is acted upon by 50 kilonewton load at its center. So that is 50 kilonewton. I take it as P max or WO max or whatever you want to call it, it's load, right? So therefore, M max is equal to P max into L by 4. WL by 4 is equal to P max L by 4. So P max is 50 into 10 power 3, correct? Into length is 500 mm, length of the bar divided by 4. Okay, so this is M max. Okay, this will give you bending moment maximum. Now we know bending stress is given by M by Z. So now I have M minimum, M maximum. So therefore I have to get sigma minimum and sigma maximum with these two values of moments. Okay, do you agree with me? So therefore sigma B minimum is equal to M minimum divided by section modulus. So therefore sigma B minimum is equal to M minimum is what? 20 into 10 power 3 into 500 divided by 4. Okay, can we simplify, or you can keep it as it is? Just simplify this and give me the value. M minimum, or simplify that, what you will get? 20?
25 into 10 power 5 for M minimum.
20.
Okay.
Please come back. Please
Sigma,
come back.
sigma.
25 into
10 power 6.
25 into 10 power 6 or 10 power 5?
6 or 5.
Yeah, divided by Z. This is sigma B minimum. Similarly, sigma B maximum will be M max divided by section modulus. So therefore, sigma B max is equal to, what is M max here? 50 into 10 power 3 into 500. So I can do that substitution. 10 power 3 into 500 divided by 4 into Z. So therefore, what is the value of sigma B max? Sigma B max is equal to, simplify and give me this value there. 62.5 to 10 power 5, correct?
62.5 into 10 power 5.
5 divided by section modulus. This is sigma B max. Okay. Now what we need to find out? We know sigma B minimum, sigma maximum. So find out sigma mean, that is equal to sigma max plus sigma minimum divided by 2. Okay. That is B here. So what you get here? 62.5 plus 25. How much it is going to be? 87.5 divided by 2. What is the value? Yeah, 87.5 divided by 2.
43.75.
43.75 into 10 power 5 divided by Z. Correct? Am I correct here? Sigma mean, that is 62.5 plus 25. Okay, that's going to be 87.5 divided by 2. Similarly, sigma amplitude is given by sigma B max minus sigma B minimum divided by 2. Okay, so therefore sigma amplitude is equal to 62.5 minus 25 divided by 2. Give me this value. Give me this value, sigma amplitude. It is 18.75, correct? 18.75 into 10 power 5 divided by Z. So now we know the value of stress amplitude, mean stress, and we have the value of ultimate stress, yield stress, endurance stress. So what is the Soderberg equation that we have got? According to Soderberg relation, the equation is given by Kft into sigma A divided by ABC into sigma endurance plus mean stress divided by yield stress is equal to 1 by factor of safety. Okay. So KFT if not given, we are going to take it as 1 over here. Sigma amplitude, we know. Sigma endurance is 350 given in the problem. Mean stress is now we have calculated. Yield stress is 500 megapascal. Factor of safety is 2. So you will get Z. So from Z, we will get the value of diameter. Okay. That is 1 into sigma amplitude is 18.75 into 10 power 5 divided by Z. So 1 into A is 1, 0.85 into 0.9 into Z into endurance strength is how much? 350 plus mean stress is, can you see here? I don't think you can see. So substitute, get me the value of Z there. Okay, complete up to that and then get me the value of Z. Please note down. Any doubt here? Anybody? See, what you can do here is you can straight away take M minimum by Z straight away instead of going for these two steps. Of course, 1 or 2 problems we will be able to do that. So please note down. Anybody? Any doubt in this? Are you able to understand? Please note down and give me the value of Z. Give me the value of Z and diameter. Z is equal to pi d cube by 32 is what we finally get. That is equal to, give me the value of Z after substitution and simplification. What's the value of Z?
Z, I'm getting 31505.6.
31505.6 exactly is what I got that. That is 31505.6. 31505.6.
Yes.
So from there, you will get D is equal to,
68.46.
that's correct. 68.5, that is 69 mm. That is the value of diameter. So same thing, now with Goodman's relation, instead of sigma y, substitute sigma u and then get me the value of diameter. Get me the value of diameter. Others, please note down step by step. Finished, huh? Did you finish?
That is 2747.14.
2747.14, that's correct. And D will be 66, correct? From Goodman's
Yes, sir. 65.4. So,
Yeah. 65.4, that is 66 mm. Yeah. So others, those who are still doing, for Goodman's relation, instead of sigma y, you substitute the value of ultimate stress, that is 650 over here, and you'll get diameter to be equal to 66 mm. Have you noted down? Have you noted down? Take down the next problem. Take down the next problem. Anybody needing time to note it down?
1 minute, sir.
This was asked for 16 marks in 2017 of your exam. Note down. A simply supported beam, a simply supported beam has a concentrated load at its center. A simply supported beam has a concentrated load at the center, which fluctuates from a value of P to 4P. Fluctuates from a value of P to 4 times P. P to 4P. Full stop. The span of the beam is 500 mm. The span of the beam is 500 mm. The span of the beam is 500 mm. And its cross section is circular. With a diameter of 60 mm. With a diameter of 60 mm. Full stop. Taking for the beam material, an ultimate stress of 700 megapascal, taking for the beam material an ultimate stress of 700 MPa, comma yield stress of 500 MPa, comma yield stress of 500 MPa, comma yield stress of 500 MPa, comma endurance limit of 330 MPa, endurance limit of 330 MPa, for reversed bending, and a FOS of 1.3 and a FOS of 1.3. FOS of 1.3. Full stop. Calculate the maximum load of P. Calculate the maximum load of P, capital P. Calculate the maximum load of P. Full stop. Take a size factor of 0.85. Take a size factor of 0.85, comma, surface finish factor of 0.9, surface finish factor of 0.9, and fatigue stress concentration factor of 1. Fatigue stress concentration factor of 1. Okay, it is similar to the previous problem. I'll go through the problem. Please look into the book. Please look into the book. A simply supported beam has a concentrated load at the center which fluctuates from a value of P to 4P. So that is, you have a bar which is given, which is loaded at its ends, or a simply supported beam, and a central point load which varies from P to 4 times P, and the span of beam is 500 mm. So the length of the beam given in the problem is 500 mm, and its cross section is circular with a diameter of 60 mm. So the diameter of the bar is given as 60 mm in the problem. Taking for the beam material an ultimate stress of 700 megapascal, that is sigma u is equal to 700 megapascal. Then what is given? Yield stress of 500 megapascal, sigma y is equal to 500 megapascal, and endurance limit stress of how much? Endurance limit stress of 330 megapascal given in the problem, and factor of safety is equal to 1.3, n is equal to 1.3. Calculate the maximum load P. Take size factor, that is, the value of B is equal to 0.85, surface finish factor C is equal to 0.9, fatigue stress concentration KFT is equal to 1. Since it does not talk about load factor, we take it as 1. We need to find the value of P. This is what we need to do. So from the problem, we can extract that L is equal to 500 mm. Okay. So again, it is a beam with 2 loads. Consider that. So you will have sigma B given by M by Z. Correct? So this is the bending equation because it is subjected to transverse load at its center. So it's a simply supported beam with central point load. You can consider it as two problems, with one as P and another with a load of 4P. So what I am going to get is M minimum here is equal to P minimum into L by 4. That is, P minimum is nothing but P into length is 500 mm divided by 4. So M minimum I am going to get is how much? 125 P. Correct? This is minimum moment. Then M max is equal to P max into L by 4. So that is 4P into 500 divided by 4. So 4 and 4 goes off. What I am going to get, M max is equal to 500 P. Correct? Are you there? Are you there? Can you hear me? Someone please say yes. Yeah. Yeah. So M minimum, M maximum we could find out. Then what do I have to find out? Sigma bending minimum is equal to M minimum divided by Z. Correct? That is equal to M minimum is what? 125 P divided by section modulus pi d cube by 32. What is diameter? 60 mm given in the problem. Pi d cube divided by 32. So the sigma minimum after simplification of this, what I am going to get is sigma minimum. Okay. Can someone give me what is 125 P into 32 by pi d cube? Can anyone give me this value? Can anyone give me this value?
So I'm rolling 0.006 p, sir. Yes, sir. Like 5.89.
Into 10 power minus 3 P. Okay. It's almost same that. Correct? Next, sigma B maximum is equal to M max divided by section modulus Z. M max is how much? It is 500 P, 500 into P into 32 divided by 5 into 60 cube, that is pi d cube. Okay. So with this, I am going to get sigma max to be equal to, sigma max is equal to, what I got is 0.0236, 0.0236 times P. So sigma max and sigma minimum, I got sigma mean to be equal to sigma max plus sigma minimum divided by 2 will give me the sigma mean to be equal to 0.0147 P. This is mean stress. What is stress amplitude? That is sigma max minus sigma minimum divided by 2. So what is that stress amplitude that I am going to get? What I got is 8.9 into 10 power minus 3 P. So this will give me stress amplitude. Now I got mean stress, I got stress amplitude, I am given field stress, endurance stress, factor of safety, value of ABC and KFT. So go to relation given by KFT into sigma A by ABC into endurance plus mean stress by yield stress is equal to 1 by factor of safety. Okay. Substitute the values. 1 into sigma A is how much? 8.9 into 10 power minus 3 times P divided by A is 1, B is 0.85, C is 0.9 given in the problem. Endurance limit stress is 330 plus mean stress is how much? 0.0147 P divided by yield stress is 500 megapascal is equal to 1 by factor of safety given is 1.3. Okay. So this you will get the value of P. Give me the value of P. Note down, and give me the value of P there. All of you please note down. If you have any doubt, please let me know. Note down clearly. Answer your roll call. One,
Ranger.
2, Abhishek GL. Can you hear me? Abhishek GL?
Excuse me, sir.
Yeah.
Sir, is that 60 cube?
Pi d cube, yeah, it is 60 cube. Pi d cube by 32 is section modulus, no?
Yes, sir. Yes, sir.
So therefore, diameter is 60 mm given in the problem, so it is going to be automatically 60, correct?
Yes, sir.
Yeah. 3, 4,
Present, sir.
5,
Yes, sir.
6, Anwar, 7,
Present, sir. Sir, present, sir.
8,
Present, sir.
9, 10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15, 17,
Present.
15.
Present, sir.
15 present, sir.
Darshan present,
Yes, sir, present.
17,
Present, sir.
18, 19, Guda Jayant Reddy, 20, 21,
Yes, sir.
22,
Present, sir.
23,
Yes, sir.
24,
Present, sir.
25.
Present, sir.
Saksham Singh, are you there? Sorry, Karamjit Singh, are you there? Who is telling yes? Chaitanya Vamshi, are you there?
Yes, sir. Present, sir.
26, Avasti, 27, 20, 30, 31, 32, 33, Narendra, 34,
Yes, sir.
35, 36, 38, 39, 40,
Yes, sir.
41,
Yes, sir.
yeah, 40,
Yes, sir. 41.
yeah, 42,
Yes, sir.
43,
Yes, sir.
44,
Present, sir.
46, 47, 48, 49, 50, 52,
Yes, sir.
53,
Yes, sir.
54,
Yes, sir.
55, 56, 57, 58, 59, 60,
Yes, sir.
61, 62,
Yes, sir.
63, 65, 66,
Present, sir.
67, Saksham Singh. 400,
Yes, sir.
Chaitanya. Madiwal,
Sir,
Nisha?
Chaitanya.
Yeah?
Sir, Chaitanya, sir. Attendance.
Yeah, Chaitanya present I have taken. Nishant, Ramesh, Shashank. Shashank.
Yes, sir.
Akshat BS,
Present, sir.
Sautrik Roy,
Present, sir.
Mahima Raj, Srivatsan,
Present, sir. Present, sir.
yeah, Suman Xavier, Madan Kumar, Manu Yeke, Shadab Khan, Ganesh R,
Yes, sir.
Vijay Kumar,
Yes, sir.
Rishi S,
Yes, sir.
Zahir Hussain. Yeah, what is the value
Sir,
of
excuse me, sir. Was I audible, sir?
who?
Akram Anwar, sir.
Akram I have taken. Yeah.
Okay, sir.
Yeah. What is the value of P?
11.99 kilonewtons.
Yeah, what is the value? P is 11?
11.99 kilonewtons.
Yeah, 11,889 is what I got. Maybe closer to that. 11,889.19 newtons. Okay, maybe it's closer to that, right? So according to Goodman, what's the value of P? Please calculate from Goodman's relation. Instead of sigma y, substitute the value of sigma u there. Ultimate strength 700 megapascal. So from Goodman's, what's the value of P that we get? Please give me this value also.
1367.
Yeah, 13663.1 Newton, correct? Okay, so according to Goodman, that's what we get. Take the next problem. Take this problem. This was asked for 14 marks. Determine the maximum load for. Determine the maximum load for. Determine the maximum load for simply supported beam. Simply supported beam. Cyclically loaded as shown in figure. Cyclically loaded as shown in figure. Full stop. The ultimate strength is 700 megapascal. The ultimate strength is 700 megapascal. The yield point in tension is. The yield point in tension is 520 MPa. 520 MPa. And endurance strength in reverse bending is. Endurance strength in reverse bending is 320 MPa. 320 MPa. 320 MPa. Full stop. Use FOS of 1.25. Use FOS of 1.25. Full stop. The loading size and surface correction factors are the loading, size and surface correction factors are 1.75 and 0.9 respectively. 1.75 and 0.9 respectively.